So let's start off with just reading it, okay, and looking at some key words here. Flying in London with a tailwind. All right, I know what these mean. Tailwind. Plane averaged 186 miles per hour. On the return trip, the plane only averaged 152 miles per hour while flying back into the same wind. Okay. So we got to look at that really fast, and then we have to figure out what is the speed of the wind. So how fast is the wind? So we got two things going on. We're trying to figure out what is W, right? And then how fast would the plane be going if there were no wind? So we got two things we're trying to figure out. What's the speed of the wind, and what's the speed of the plane? So tailwind. What is tailwind? Okay. So if a plane is flying, let's say a plane is flying this direction, right, east, right? A tailwind means the wind is pushing and making it go faster from behind, the tail of the plane. So the wind is pushing or making the plane go faster. So a tailwind usually means it's going faster than the speed of the plane. So you got how fast the plane is going, right? But then you have the wind also pushing you to make you go a little faster. Then, of course, if you have that same wind and you're flying into it, on the way back, that wind that you're running directly into, you guys know when you try to run into the wind, that kind of slows you down. It's hard to run. It's the same idea. So you're going to go slower when you're going into the wind. So you can see that when there is wind behind you, you're going 186 miles per hour. But when you're going into the wind, it's slower. Anytime you run directly into the wind, it's harder. It's more work. Okay, so we're trying to figure out, well, what if there was no wind at all? Slowing you down or speeding you up, how fast would you just go on your own? And then how much is that wind speeding you up or down? Okay, so we have two things we're looking at. I'm going to use W for wind and P for plane. So that's the speed of the wind and the speed of the plane. So we know with a tailwind, again, that's going to be the speed of the plane, right, plus the speed of the wind, right? That's going to equal 186 miles per hour. So however fast the plane is going plus however fast the wind is, we know that adds up to 186 because that wind is pushing the plane along. But then on the way back, the plane's flying the same speed, right? But it's going slower because the wind is subtracting its speed. It's making it slower. So on the way back, when you're going into the wind, you go slower, right? And it's only 152. So you can see the faster time is with the plus because that's more speed because of the wind, and the slower speed is with the minus because it's slowed down by the wind. So always make sure those line up and you'll be okay. And now, from here on out, is a system of equations that you know how to solve. Okay, so you guys know what the next part is. We have variables that cancel out, so that eliminates. All right, we have 1p plus 1p, which equals 2p. All right. And if we add these up, we'll get 6 plus 2 is 8. 8 plus 5 is 13, so 3 can carry the 1. All right, so 2 times the speed of the plane is 338. So that means the plane actually is going half of 338. So we want to take 338 and divide it by 2. See what that is. And feel free to use a calculator if you have one handy. All right. But if not, we can still figure it out without it. Okay. And it looks like the speed of the plane is going to be 169 miles per hour. So make sure on your answer that you do use the units as well. So miles per hour. And just like before, not finished, we needed to figure out, well, how fast is the wind? So remember, we now know that the speed of the plane is 169 miles per hour, and then plus the speed of the wind, and that will equal 186 miles per hour total. So how fast is the wind going if we need to get up to 186 miles per hour? All right, so just like before, it's the same steps as we've been doing. You can subtract the speed of the plane from both sides. All right. Again, use a calculator if you need to. Okay. So we can see the speed of the wind is 17 miles per hour. And then we can always check this, like we talked about last week. So is 169 plus 17 equal to 186? Is the speed of the plane plus the speed of the wind 186 miles per hour? And is the speed of the plane minus the speed of the wind equal to 152? And if it is, and of course it is here, then you have the right answers. Now, we don't really have to put these in a coordinate form, but if we did, we're going to put them in alphabetical, so we'd put P, comma, W. But we really don't need to do that for these word problems. We just have to write out P equals, and then of course have the units for each one. And the units will usually be the same. Okay? So that's how we can do one of them on the front. Why don't we go ahead and start number 2 together and let you guys solve it. Okay? So this time instead of a plane, it's going to be a boat, and so instead of wind, there's current. So wind and current are kind of like the same thing, just one is in air, one is in water. There's no wind in the water, there's a current. So that's where it's flowing. So we're going to use, instead of W, we'll use C for current. And we'll use B for boat. So you have to kind of figure out what you're going to call your two variables from the very beginning. Now, with the current, if you ever swam with the current, that's when you go faster. So that's very similar to, like we just did up here, like a tailwind. So with the current, all right, that's faster. So we know the speed of the boat plus the current is going to be only 15 miles per hour. We're not going too fast. And then when we go against the current, that's like flying into the wind. On the last problem, so the speed of the boat minus the current that slows you down, it slows down to 7. So again, notice how the plus sign has the bigger number. So plus, when you're adding something, you should get a bigger number. Subtracting, you'll get a smaller. So always make sure that's true when you're setting up. It's not necessarily true that the first equation is plus and the second one's minus. It could be reversed. Just look at the numbers, which one's big, which one's small. Okay, go ahead and solve that. Go ahead and solve that and see what you get. Okay, so we get 2b equals 22. So b equals 11 miles per hour. So the speed of the boat is 11 miles per hour, which makes the speed of the current to be 4 miles per hour. So make sure you have the B equals 11 miles per hour as well as the current equaling 4 miles per hour. Okay, go ahead and set up number 3. See if you can set up number 3 on your own like we did on 1 and 2. Okay, so take a look at the back. Now, assume that you're trying to get two equations with two variables. So that really helps to know kind of what you're aiming for from the beginning. But in the same way, let's identify what it is you're trying to find and figure out. Okay. So we have two types of flowers are being planted. We got rose bushes and geraniums. Okay, they bought the supplies at the same store, so we know they cost the same. One person spent $100 on 10 roses and 10 geraniums, and someone else spent $96 on 10 roses and 8 geraniums. Not as many flowers total, she had 20, he only got 18, so it's a little bit cheaper. But just like before, we were trying to find, well, how much is the wind, how much is the current, how much is the speed of the plane. We're still trying to find the cost now of two different things. How much are the roses? Okay, so I'm going to call those R. And what's the cost of the geraniums? So I always want to go through and just kind of abbreviate the two things that you're trying to figure out the answers to, the cost of two of them. So each of these, the units are going to be dollars, right? That's what we're looking for, how much they cost. So when we solve this, we'll get two numbers, and that's how much they each cost. Now, what's something different is that we're not just doing a speed of the plane, speed of the current. We're doing the cost of 10 roses. So we know that 10 times R, right? 10 roses and 10 geraniums costs $100. And then for Mark, we had 10 roses as well, and 8 geraniums, and we know that's 96. And we said for these, well, we do need one positive and one negative, but to cancel out, but these are both positive. So we said last week, go ahead and multiply one of them, top or bottom, by a negative. Doesn't matter if you do the top or the bottom, it's as long as you do only one of them. Okay? So I'll multiply the bottom one by negative. So I'll get negative 10 times R minus 8G equals negative 96. So we have 10R plus 10G equals 100. Alright, so one is positive and one is negative, and they're the same number, so that's how the equals zero. One has to be positive and one has to be negative. And from here on, you already know how to solve the rest. I'll just let you do that. And just make sure once you get your two answers, okay, you have the roses and you have a dollar sign and you have the geraniums, and those are also money. So make sure you have dollar signs on both numbers, and that's how much they cost. All right. And all of these on the back set up the same way. So you just have to multiply one of them by -1 in order to solve. Okay? But we're just using what we learned last week for something a little more realistic. Okay? And you can see how it can really be used to solve real life problems. Alright, so I'll just finish this one up and let you guys work on the rest. So we get 10 minus 8, which is 2. And 100 minus 96, which is 4. So a geranium looks like it costs $2. If geranium costs $2, you could figure out, well, if 10 roses and 10 geraniums at $2 a piece cost $100. You could just solve this and find out how much each rose costs. So this is 20. 2 times 10. Subtract the 20. So we know the cost of the 10 roses is $80. So if 10 roses cost $80, then we know each rose costs $8. Right? 80 divided by 10, 8 over 1, which is 8. So $8 for each rose bush and $2 for each geranium. And if we plugged it back in here, we could do a check to make sure, well, does 10 roses and 8 geraniums cost $96? That'd be 80 plus 2 times 8, which is 16. 80 plus 16 is 96. So I can check it and make sure it does work. Now the problems might be different worded. Instead of, you know, roses and geraniums, it could be something else we're trying to find out the price for. So like over here, we're planting grass and ivy. I'm going to use a V for ivy just because the I is kind of weird in the equation. But yeah, so just use the same idea. Okay, someone spent $39 here for two grasses and 7 ivies, and then someone else had 2 grasses and only 2 ivies, and they spent this much. So you can still solve it. It's a very similar type of equation, just using different things. And on number 7 and 8, they're more about selling tickets. Very similar. Okay, we have vans and buses. So 7V plus 9B is 434, and we have 2 vans and 9 buses. That's 394. And again, we can solve that as well. Okay. So I'll let you guys work on the rest of that. Hopefully we can get it done by the end of the period. And tomorrow we'll just do a day 2 that's very similar to this, but you'll have to multiply one or both equations in order to solve, but very similar type of word problems. Okay. So go ahead and keep working, and when you get finished, let me show it to me. I'll be looking very carefully to make sure all your answers do have units. So once you get V equals, make sure you say, oh, it's 7 vans, right? And it's going to be 10 buses or something like that. But actually say 7 of what, 10 of what. You actually have to put some units, whether it's vans, buses, grass, ivy, or like on number 5, it was just dollars. So you have to say, well, what does that number mean with some units? Okay? All right. Go ahead and work on that for the rest of the period. Get finished early, feel free to try to finish up any Khan Academies that are not done yet. Check out your grade.